Alright everyone, let's get started. Today, we're going to talk about sum and difference problems. That means situations where we know the total of two numbers and also know how much one is bigger than the other, and we want to figure out what the two numbers actually are. Whenever you know both the sum and the difference, there's a simple way to find the two numbers. The bigger one is half of the sum plus the difference, and the smaller one is half of the sum minus the difference. That's the key idea we'll use today. Let's look at our first example. Max filled two boxes, box A and box B, with a total of 102 small parts. He then moved 24 parts from box A into box B. After the move, box A had 4 fewer parts than box B. Let's solve this by equations. Call the original number of parts in box A, A, and call the original number in box B, B. The first equation is that A plus B equals 102. After moving 24 parts from A to B, the new amount in box A is a minus 24, and the new amount in box B is B plus 24. The problem tells us that after the move, box A has 4 fewer than box B, so the second equation is a minus 24 plus 4 equals B plus 24. Simplify that second equation by combining the minus 24 and plus 4 into minus 20, then move terms to one side. A minus B equals 44. Now we have two equations in words. A plus B equals 102, and A minus B equals 44. To solve these, add the two equations together. The left side gives 2 times A, and the right side gives 146. So 2 times A equals 146, which tells us that A equals 73. Substitute A equals 73 back into the first equation. A plus B equals 102. That gives B equals 29. So originally box A had 73 and box B had 29. After moving 24 parts, box A has 73 minus 24, which is 49, and box B has 29 plus 24, which is 53. You can check that 49 plus 53 equals 102, and that 53 minus 49 equals 4, as required. I'll also restate the neat reasoning method for this problem in plain language. After the move, box A is 4 less than box B. If we remove those 4 extra from box B, the two boxes would be equal and would total 98, so each would have 49. Put the 4 back on box B to get 53 there and 49 in box A. Is this much easier to understand? But the algebraic equation method we walked through shows how to set up and solve the system step by step using variables. Next example involves 3 numbers, A, B, and C. We are told that A plus B is 59 more than C. We are told that B plus C is 49 more than A, and we are told that A plus C is 85 more than B. The algebraic approach is to write these 3 relationships in words. First, A plus B equals C plus 59. Second, B plus C equals A plus 49. Third, A plus C equals B plus 85. Now add all 3 left-hand expressions together and add all 3 right-hand expressions together. On the left you will have A plus B plus B plus C plus A plus C, which is 2 times the sum A plus B plus C. On the right you have A plus B plus C plus the numerical excess is 59, 49, and 85. So 2 times the sum of A, B, and C equals the sum A plus B plus C plus 193. Subtract the sum A plus B plus C from both sides in words, and you find that the sum A plus B plus C equals 193. That is the total of the 3 numbers. Third example is about trees in a garden. We are told that the number of trees that are not tea trees is 38. We are told that the number of trees that are not osmanthus trees is 29. We are also told that the total of tea trees and osmanthus trees together is 25. Using algebra, let the number of tea trees be T and the number of osmanthus trees be O, and let the total number of trees be N. From the first condition, N minus T equals 38. So N equals T plus 38. From the second condition, N minus O equals 29, so N equals O plus 29. Equate these two expressions for N. T plus 38 equals O plus 29. Rearranging that relation gives O minus T equals 9, meaning there are 9 more osmanthus trees than tea trees. The third condition tells us that T plus O equals 25. Now solve the two equations in words. The sum of T and O is 25, and O minus T equals 9. Add those two relations together. T plus O minus T equals 25 plus 9, which simplifies to 2 times O equals 34, so O equals 17. Then T equals 25 minus 17, so t equals 8. Therefore there are 8 t-trees and 17 osmanthus trees. A quick reasoning description. Because counting non-t trees gives 38, the total must be t plus 38. Because counting non-osmanthus trees gives 29, the total must also be osmanthus plus 29. Equating them yields the 9-tree difference, and combining with the total 25 gives 8 and 17 for the two type of trees. According to the formula we learned that the bigger one is half of the sum plus the difference, and the smaller one is half of the sum minus the difference. Fourth example is a shopping problem. Alex bought 2 notebooks and 3 folders for $19. Ellie bought 3 notebooks and 2 folders for $16. All notebooks cost the same and all folders cost the same. Solve algebraically by letting the notebook price be n and the folder price be f. The first equation in words is 2 times n plus 3 times f equals 19. The second equation is 3 times n plus 2 times f equals 16. To eliminate a variable, multiply the first equation by 3 and the second equation by 2 so that both have 6 times n on the left. The first scaled equation becomes 6 times n plus 9 times f equals 57, and the second scaled equation becomes 6 times n plus 4 times f equals 32. Subtract the second scaled equation from the first scaled equation. The 6 times n terms cancel and you are left with 5 times f equals 25. Therefore f equals 5. Substitute f equals 5 back into one of the original equations, for example 2 times n plus 3 times 5 equals 19, which simplifies to 2 times n plus 15 equals 19, so 2 times n equals 4 and hence n equals 2. Therefore a notebook costs $2 and a folder costs $5. The reasoning method gives the same result. Subtracting the two purchases shows that a folder costs $3 more than a notebook. Adding the two purchases shows that notebook plus folder costs $7, and applying the sum difference formula and solving those two facts gives 2 and 5. Finally, the running track example. The circular track is 400 meters. When the two friends run toward each other from the same starting point, they meet every 2 minutes. When they run in the same direction, the faster catches the slower every 20 minutes. Let the faster runner's speed be v sub f and the slower runner's speed be v sub s. Let's treat the first unknown as the faster speed and the second unknown as the slower speed. When they run in opposite directions, their closing speed is the sum of their speeds, and they cover 400 meters together in 2 minutes, so the sum of their speeds is 200 meters per minute. When they run in the same direction, the faster gains on the slower at a rate equal to the difference of their speeds, and it takes 20 minutes for the faster to gain a full lap of 400 meters, so the difference of their speeds is 20 meters per minute. Now we have two equations, the sum of the speeds equals 200, and the difference equals 20. We can directly use the sum difference formula to get the answer or solving the equations in the following way. Add these two relations together. The left-hand side becomes 2 times the faster speed, and the right-hand side becomes 200 plus 20, which is 220. So 2 times the faster speed equals 220, and therefore the faster speed equals 110 meters per minute. Substitute back to find the slower speed. Slower speed equals 200 minus 110, which is 90 meters per minute. Thus the faster runner runs at 110 meters per minute and the slower at 90 meters per minute. That completes the algebraic, equation-based walkthrough of the sum and difference problems from the first 5 pages. Each time we had 2 unknowns and 2 linear relations, we set up the relations in words, combined them by addition or subtraction to eliminate one variable, solved for the remaining variable, and then back-substituted to find the other. The alternative reasoning approaches we mentioned give intuitive shortcuts, but the algebraic method is systematic and always works. Next time we will move on to some multiple problems, where the relationships involve multiples or ratios rather than differences. See you in the next lesson.